So in today's class, we will be looking at charges, Coulomb's law, and electrostatic force. So first, let's start with the fundamental part, which is charge. So charge is a property that is possessed by every object or atom, and it is associated with the number of electrons and the number of protons that a body has. So what we know about charge is that it basically is affected by the number of electrons and the number of protons that a body has. So there are only two types of charge, even though many people consider neutral charge as being a type of charge, but there are two types of charge. So the first one is positive, and the other one is negative. So the negative charge is associated with electrons by convention, and positive is associated with protons. A body is neutral if it has the number of protons is equal to the number of electrons. So as you know, obviously, if it has more electrons, then that body is negative. If it has more protons, it is positive. Now let's look at the four main properties of charge. So the first one is that there are two kinds of charge. We already said that. So the second property is that similar charged bodies repel each other and vice versa. So if they are positive and negative, they obviously attract each other. The next property is that electric charge is always conserved. I'm going to give you a very basic analogy to understand this. So for example, when sodium and chlorine react to make sodium chloride, this is the balanced equation. So sodium loses one electron from each atom. So if it loses two atoms, it obviously is going to go to the two atoms of chlorine to form this particular compound. So what we can see is that both electrons are not going to disappear. They actually went to another atom. The next one is energy charge is quantized. So the easiest way to understand this is using this visual diagram. As you can see in this visual diagram, in the middle we have a lot of proton and on the outside we have tons of electrons. So what we mean by electric charge is quantized is that in every single atom, the first level, level 1, or the ground level, has a certain amount of energy. For example, it could be 32 joules. And then the next one could be 42 joules. So in order for this atom to lose this particular electron, it needs to get 42 joules. So let me show you this using one formula that is really important. So Q stands for charge, N stands for take any integer above 1, including 1, and E is a constant number, which is 1.6 times 10 to the power of minus 19 Coulomb. So let me talk about what E is first. So E is called the elementary charge, and it's basically the smallest amount of charge that can be carried by one electron or proton. So this, if it's an electron, then it is negative 1.6 times 10 to the power of minus 19. But if it's a proton, then it's the same as this, which is 1.6 times 10 to the power of minus 19. Now let's do an example problem. So here's our question. It says, what number of proton is required to make 1 coulomb of charge? So the easiest way we can do is first we need to define the given. So we're already given charge, and we know that E is elementary charge, which is a set constant. First, we need to derive the formula for the number of protons. So obviously N will be the number of protons here, and then we're gonna say N is equal to Q over E. Then when we calculate the number, we would get 6.5 times 10 to the power of 18 electrons. Now, let's talk about the electrostatic force. So electrostatic force is a type of force of attraction or repulsion between two charged bodies. So as you know, gravity is a very attractive force. So if gravity is only positive, then electrostatic force is both positive and negative. Now let's talk about our guy Coulomb. So Coulomb basically gave a law that is very similar to Newton's law of gravitation, and it basically was related to the force that one charged particle exerts on another charged particle or a neutral particle. So what he basically said is that 2-point charges exert an electrical force on each other that is directly proportional to their product of their charges and inversely proportional to the square of their distance. So let me write that down and let me explain and break down everything. So this is how we can state the Coulomb's law very simply and condensed, but let me show you the actual formula. So F stands for the electrostatic force, and then we have the product of their charge, which is Q1 and Q2. And then under there we have the distance between those two charges squared. So one thing everybody shouldn't forget is the constant K. So the constant K is formally known as this number, 9 times 10 to the power of 9 Newton meter squared per Coulomb squared. So this is K, and it should not be forgotten. So K is known as Coulomb's constant or electrostatic constant. So this is the question. I'm gonna give all of you a few minutes to do this, so feel free to pause the video and do these questions, please. The first thing that we need to do is take out the given. So what we need to find is electrostatic force and also the number of excess electrons present in the water. So let us start with the electrostatic force. So obviously we know the formula, which is, so how we're gonna do this question is first we need to write down the equation. So, and then plug in the numbers. R squared will be 0.01 times 9 times 10 to the power of 9, which will be equal to 9 times 10 to the power of 13. Now let's do the second one, which is finding the number of excess electrons. So as you know, the formula is this. This question doesn't have every information provided, so we're just going to take the Q as 1. First, let's derive the formula like I did before. So it's going to be Q over E, which will be equal to 1 over 1.6 times 10 to the power of minus 19, which will give us the previous answer as well, which is 6.25 times 10 to the power of minus 18. So this is how you do questions related to electrostatic force and also charge. So the next topic we're going to look at, the last one, is going to be the force on a charge due to multiple electric charges. Now first we need to know what a very critical principle is in this topic, which is the superposition principle. So electrostatic force is a vector quantity because it's obviously a force. So if more than one force is acting on this charged particle, then the resultant force will be the sum or the vector sum of all of these forces. So this concept is explained by the superposition principle. So let's say this is a charged particle, positively charged particle. So if it has a attractive force this way and an attractive force this way as well, then the resultant force of this charged particle, or the electrostatic force of this charged particle, will be this, or the vector sum. So this will be R, and this will be force 1, force 2. So it will be the vector sum. So for example, if we have a system with n number of stationary items, So in this particular system, we have 4 charges, and what we need to know is the amount of force that is exerted on this Q1. So in order to find that, we use the formula F net, which is equal to F12 plus F13 and F14. So in these particular cases, we need to calculate the force exerted by each object separately, and then we add them together to find the net force exerted on Q1. So we basically use this formula where we change only these numbers, Q1 and Q2, and then find each force right here. So after we find them, we basically add them up. So guys, this is going to be the general example that we're going to do for this particular topic. So feel free to pause the video and do this question. Okay, so let's continue. What we're given here is that there are 3-point charges. So on the x-axis, so the first charge is on 6 microcoulomb at x1 5 centimeters. The second charge we're given is -5 microcoulomb at -3 centimeters, and then we're given +2 microcoulomb at the origin. So what is the magnitude and direction of the electrostatic force acting on Q3? So we're going to do these questions based on Q3. So first, let's get out the given ones. What's required is the net force and also the direction. So first, let us start up with the force that was exerted on Q3 by Q1. But first, let's draw like a physical diagram so we can easily visualize everything. So this is how we draw out the diagram, and now we can easily visualize what we're working with. So like I said, let us start with the force exerted on F3 by F1. So as you can see, when we plug in all the numbers, it's going to look something like this, but I changed this form into a scientific notation form so it's easier to work with. Now when we multiply everything, we will get the value 43.2 newtons. The next step we're going to take is the force exerted by Q number 2 on Q number 3. So now, as you can see, this was supposed to be negative, right? So from here, Q2, it's negative, but here it's positive. Well, this is because according to the formula, the Q1 and Q2 needs to be put into an absolute value. Now our final answer is going to be 100 newtons. Okay, so the next step is determining the direction. When finding the direction, if both charges exert forces on the same direction, then we take both of them as negative. So as you can see, Q3 and Q1 are both positive, so it's going to be a repulsive force. So in the left direction, we're going to take Q1 on Q3, it's going to be positive. Both Q2 and Q1 exert force on the same direction, so they're both positive. So it's going to be 100 newtons. Q2 on Q3 is also going to be positive, so it's going to be 43.2. And the next thing we need to do is add them up. When we add them, it's going to be 100 plus 43.2, which is 143.2 newtons in the left direction. So the left direction is obviously the negative x-axis. So yeah. So guys, in our next video, we will be going over lesson review questions, so you guys can make sure that you fully understand or fully grasp the idea of this important topic.